Hey, hey guys. So I wanted to tell you that I figured out what happened with our projectile motion. We did not take into consideration, or at least I didn't, that when the projectile leaves your launcher and it goes up and comes back down to this point, it actually has a velocity. So it has an initial velocity, so we have to use the equation change in x equals velocity initial times time plus 1/2 at squared. And to find time, we have to use the quadratic equation. So I'm going to show you how to do it with some numbers that should be close to the numbers that you got. So if your initial launch velocity was 3 meters per second, okay, and you did your 3 sine 35 degrees because your angle was 35 degrees, okay, you would have gotten your y velocity as 1.72 meters per second and your x velocity as 2.46 meters per second using cosine. So that'd be your horizontal velocity and your vertical velocity. Now, we need to know the total time that it's in the air. So it's going to come off, it's going to go up, and then come back down, and hopefully it's going to land in our cup if we put our cup in the right place. So we can use our vertical velocity to find out the time that it takes for it to go up and get up all the way to the peak of its arc and be 0 meters per second, and then the time it takes to come back down from where it was originally shot at. So if we do that, we use the equation change in v equals a times t. So negative 1.72 meters per second, which is my velocity, equals negative 9.8 divided by t. If we take that negative 1.72 divided by negative 9.8, we get a time of 0.176 seconds to go up, and then 0.176 seconds to come back down. So the total up and down time would be 0.176 times 2. So it takes 0.352 seconds for it to go all the way up and come all the way back from where it was initially shot. Now here's where we went wrong. It has a velocity here because it goes up to 0 meters per second, and then it comes back down, and when it's back here, it actually has a velocity of 1.72 meters per second. So 1.72 meters per second is the velocity at that point. So we have to consider that when we use change in x equals vi times t plus 1/2 at squared. That's the equation we have to use. So we also need to know our change in x. Now, if, for example, your cup was at 15 centimeters above the floor, so 0.15 meters, and from the floor to your table, or to, the launcher, the bottom where the ball is going to come out, is 0.89 meters, we can find the distance from where it was launched to the cup by subtracting how high the cup is from the table distance. So 0.89 minus 0.15 gives me that it's got to go 0.74 meters. So my change in x is going to be a negative 0.74. So negative 0.74 equals, my initial velocity is 1.72 times time. And it's a negative. My plus 1/2 negative 9.8 times t squared. So now what I need to do is I need to go ahead and put that into a form so that I can stick it into the quadratic equation. So it's going to end up being, take 1/2 of negative 9.8, so I get negative 4.9 t squared plus a negative 1.72 t plus 0.74. equals 0. So now I have my A, my B, and my C. So I just had to plug it into the quadratic equation. So negative B plus or minus B squared minus 4AC all over 2A. So negative B, so a negative negative plus or minus square root B squared minus 4 times A times C all over 2 times A. Okay. Now, when you plug those in, you end up getting that the time for the cup, that your time value is 0.251 seconds. So that's the time it takes for your projectile to go from this point to the top of your cup. So the total time of your projectile equals that 0.352 seconds plus 0.251 seconds. So the total time ends up being 0.603 seconds. Let me just double check that. So 0.603 seconds. Okay. Now, all I need to do, that's the total time of the flight, is I need to take that number and plug it in to my change in x equals v times t. So when I do that, change in x equals v times t, change in x equals my horizontal velocity, which is 2.46, times my time, which is 0.603. And when I do that, I get 1.48 meters. So therefore, I need to place my cup 1.48 meters away from where it is going to be launched. At least have the center above that. Okay, guys, I hope that helps. Bye.